Hey there, welcome back. We're still in chapter 6, and it's starting to get kind of icky. We're in chapter 6, lecture 3. This is going to be about bone formation. It's not going to be a long lecture. We have the subsequent lectures after this one are going to be about bone growth when that epiphyseal plate is active, and bone remodeling. And I'll be honest, they're all kind of the same thing. So let's bounce around here a little bit and have a little, I'd say have a little fun with this, but something tells me you guys aren't having too much fun. I'm trying to get to the right thing. Okay. All right, so bone formation. So what this means is, well, there's a couple different reasons why bones form. Bones form because you're an embryo and you're a fetus, and you need a skeleton, right? Otherwise you'll come out as a puddle. So you have bone growing. In that case, you have bones growing before that epiphyseal plate becomes an epiphyseal line and at the growth plate. But you also have bone formation happening every day, even as an adult. So bones are constantly remodeling every day. Compact bone gets replaced. Your arm bones, your leg bones, all that bone gets replaced, like, I don't know, every so many years. It's slowly going, well, let me remake this again. So bones are constantly remodeling. Remodeling means I'm rebuilding it, reforming it, because it's what I do, or it's in response to what you're doing to your body and therefore your bones. And then you'll have bone formation. If you break something, you need it to heal. So what I actually want to say about this is jumping, I'm on the wrong pad, is that all of this happens in the same pattern. It's the pattern of bone growth. I'll just say bone formation. So I want to just start with this little foundation, and then we'll dive into the slides and be more specific and technical and blah, blah, blah. So the first thing you always need is you'll always need a hyaline cartilage model. All bone is stupid. I'll be honest, bone's stupid. It doesn't, well, yeah, it really is for many different purposes, but it doesn't know where to go, where to put bone down, unless somebody's telling it where to do that. So I have a hyaline cartilage model. So all bone will start out, it's not that it gets turned into bone. So cartilage model. So cartilage cells are called chondrocytes, will lay down where it wants bone to be. That's the model, where bone should be. I should probably just type this, huh? It probably would be more where bone should be. Well, too late now. And then what happens are these cartilage cells will die. They'll lay it down and then they'll start making little pits. We'll just say they'll die. We'll see fancier words later about it. Trying to scroll down. Okay, so cartilage cells will die, and then I will have osteoblasts, because they're the builders. Osteoblasts will come in because there's some sort of blood supply, and or periosteum, where they're hanging out, and they will lay down spongy bone. Now, not all of your bone is spongy bone, but it's my bone. It lays down spongy bone, kind of like as a patch, right? Some places will stay spongy bone. Otherwise, after it lays down spongy bone, it's got to then fix it. So osteoblasts might come in and convert That's where it converts. Convert spongy bone to compact bone and those repeating units of the osteons. Convert spongy bone to compact bone. And I will have osteoclast activity because osteoclast will shape the bone the proper shape and put in shape bone proper shape and put in cavities, where there needs to be a medullary cavity. So this is the basis of any and all bone formation. I have, change colors, a hyaline cartilage model. I guess I should, that's what that says. Hyaline cartilage model was established by different cells, cartilage cells, that lay down where bone should be. And then they die. They form pits. Osteoblasts will come in because it's in their yard. And they will lay down spongy bone. Maybe they'll be done if that's all they needed to lay down. But if it's not, the fourth step will be that they will then fix it and lay down compact bone from the spongy bone if that's what's needed. And osteoclasts will also have a role to remodel and shape the bone the proper shape, okay? We will see this pattern. Go back to the silly little regular word list for all of our future bone activities. All right, so we are only going to be talking about long bone growth. Long bone growth is endochondral ossification. Hold on. Oh. All right, well, we're going to... Endochondral ossification is long bone growth. Intramembranous ossification is in flat bones. So we're not going to talk about intramembranous ossification. Do I even have a slide on it? Oh, I do. But it's forming spongy bone, right? The end result is spongy bone and a periosteum with a little thin layer of compact bone in there. But again, this is not the one. This isn't even labeled. This is intramembranous ossification, and you're not responsible for this. I throw it in there because people might want it as a reference who are going further into some medical field. All right, but endochondral ossification. Do I have each one? No, I do not have each one. Individually has, well, I guess 6 steps here because there's 6 little numbers surrounded by the little blue circle. So what I first have is a cartilage model. Oh, look, we already talked about that. It's hyaline cartilage. Right, so babies are made out of hyaline cartilage. That's why they bounce. No, they don't bounce. Don't do that. And this cartilage model has an epiphysis, proximal and distal end, and it has the diaphysis, shaft area. Now what happens is I start, because I have blood supply, I have all these wacky signals going on. I start getting a bony collar here, right? This bony collar isn't even labeled. Oops, well that's what this guy is. A bony collar. And I start getting these cartilage cells growing and kind of dying. Okay, so based on the blood supply coming in, this nutrient artery is converting the diaphysis, is where I'm focusing on, right? The diaphysis gets its action first. I'm starting to get the formation of a periosteum from that bony collar, will ultimately become the periosteum. And I will have the cartilage cells dying off and bone cells replacing it with spongy bone. Okay, so when I'm getting, and that's what it even says here, right? Spongy bone. I was going to write it down, but I've just found it, so I don't need to. All right, So this step 3 is cartilage dying and spongy bone coming in. Okay. By a separate thing, osteoblasts. So this is my osteoblasts are making this happen by laying down that spongy bone. Okay, well, but the diaphysis is not made out of spongy bone, so I will have osteoclasts coming in to hollow out that diaphysis. I will have, so osteoclasts, hollow out medullary cavity. That will ultimately be filled with yellow bone marrow. And I will have osteoblasts, it's not really showing it in here, that will build compact bone out of the spongy bone. Oops. All right. So then I've got the diaphysis well on its way to where it needs to be. And that's my primary ossification center. So now I start getting the development of a secondary ossification center. So the cartilage that was at the epiphysis. My dog is snoring. Will die off in the secondary ossification center, and I will have osteoblasts come down and lay down a spongy bone. Wow. So what I have a couple things, and it's all based on this whole blood supply and the formation of this periosteum. What I have is I will have spongy bone in this epiphysis. Am I done? Yeah, I'm done, because the epiphysis is spongy bone. So it gets to stay that way. And then I leave in the metaphysis a band of cartilage. Okay, this band of cartilage is my epiphyseal plate. This is what's going to allow bone lengthening. And I'll write it over here. Allows bone length. Hold on. Bone growth and length. Because I've left cartilage in the epiphyseal plate. It's a band of cartilage that stays. Okay, band of cartilage remains. Only because it's still there do I get the ability to grow in length. I always have to have a cartilage model. So just like we said, I'm just trying to find my pen. The formation of bone, I have to have a hyaline cartilage model everywhere. Growth plates, bone itself, even when I break bone, we'll see I patch it with a cartilage model before I replace it with the bone. So I'm going to stop here because that guy's a big deal, and I'm just going to leave it at that.